Test the audio. Looking good. Camera 2. Looking good. Let's test the stream. Just on my phone. How's the audio? That's pretty good. Internet lag. Anyway, I think we have almost everything we need. Gonna post on Twitter and then get going. Let's find where's my last stream? All right. All right, just tweeted. Okay. Get on Twitter. Just close the live stream. Oh my gosh. Pop out chat. There we go. If anybody's in the chat, I'll be able to see their comments. In the meantime, all right. Well, that wasn't too loud. Trying to live stream again. I'm building my 3D printer. You can kind of see it behind me a little bit. If you're just tuning in for the first time, last year I started rebuilding a 3D printer from scratch using old components, new components, from a project called the ReDuplicator. It's got a long story in one of the earlier videos. And then life happened, pandemic happened, and I'm out of a 3D printer. Well, I have a makeshift one, so to speak. But anyway, I've been trying to use this live stream as a motivational tool to get this done, because I'd really like to have a good 3D printer again. It's based off an open source project. There's been some hiccups with the design. It's evolved since I started. I forgot to print some parts, so I used my makeshift printer to finish up the last few pieces. And in today, well, before I get on about today, I kind of did some work off camera. You can see, we'll see it a little bit later, but I assembled the full XY carriage. And so the part that I have left are the last two sections of this rebuild Flint Project Wiki. Section 8, which is the y-axis. I have some upgrades there to show off, and cabling it up with the original control system. which I will be replacing eventually. And my goal is to get this mechanically and electronically set up, even if the control system has to be reprogrammed. I have to figure that out because there's been some changes to the design. And even if things are not quite right because I broke stuff or the changes weren't fully incorporated into the parts I have, I'm not worried about that right now. I just want to get through to the last section of the wiki. So to get back into it, we're on the y-axis. Let's switch to overhead camera 2. Move my stool out of the way. Okay. We don't need this. Well, I'll put this to the side. I will have to do many little tweaks in a future time. But let's get back to where we left off. Just off camera, perfect. In the y-axis. So I installed the bearing blocks onto a new Y carriage. I bought this from Eastern Europe. It's the same design. You'll notice that just upgrade uses. I just wanted to. It seemed like a good enough design. It took forever to ship with COVID shipping issues, but it is, as the documents say, very rigid and still light. It's 3 thin plates, maybe 4 thin plates of aluminum, looks like, but then some sort of composite material. It's not FR4 as far as I can tell, but it kind of has that that composite look and feel. Obviously big cutouts to save on mass. I used 3D printed blocks, which are lighter than the original aluminums. The original screws are a little bit short for my taste. They're in there, no question, but like not well. These are just threaded in there with friction fit. Probably put lock nuts on there. The original, this is one that actually concerns me. The original screws for the Y belt are too short, so there's no way to get nuts in there. I don't have M4 screws. It's just one of the sizes that I don't typically use, and I would like to use all 4. For now, it's fine. It moves, so this won't be a good system for production. But we will truck along with that. And I got the rods. I'm gonna get the rods cleaned. They're got some gunk. I put some Teflon lubricant, which I don't know. Some YouTubers swear by it. I don't think it actually helps with rods, but we'll clean it up for now from grease and things. Always have your skin wipes handy, slightly used, but not a big deal. And that will just make sure everything is nice and clean before I insert it. I'm not being too particular, but just good general maintenance. Let's see, my desk is dirty enough where wherever I got off is fine. All right, let's just check if there's any viewers. Oh, there we go. A couple concurrent viewers. Hey everyone. Thanks for tuning in. Building 3D printer stuff. All right, so one of the issues was these blocks. The rod holders. I must have forgotten one because I only had 3. These 2, which are identical, so they're somewhere mirror. This is one for the switch and one for not. It's also taller than the rest, so I wonder if some of the designs have changed. No worries. I drilled these out with 10mm drill because we learned our lesson last time when we cracked the X-Carriage parts. But let's go ahead and follow these instructions. Install the left and right axis rod holders in the front extrusion. Insert the 380mm smooth rods. Oh, hey Alvaro. This is the 3D printer I've been complaining about that doesn't work. Let me know if you see all my mistakes. But these are around 10mm. Use 12mm M5 on the short end and a 60mm on the tall side. I have no idea what that means. That's cool. I will figure it out. It looks like slide the Y carriage onto the rods. Cool. Slide the Y-axis end stop into the back left corner, and the normal rod holder on the rear right corner. And these, you can't see it very well from these photos, but they're taking different designs. Oh man! All right, cool. Alvaro's doing some live coding later. So if you don't know Alvaro, he is an awesome coder, hardware hacker extraordinaire, and does live coding on Twitch. Right, it's Twitch only. Alvaro, feel free to leave a link to your stream. And actually, so he's in Brazil, and his last live stream was Portuguese. And surprisingly, code is somewhat universal. A friend and I were able to follow along, even though we're native English speakers and don't speak a lick of Portuguese. Okay, cool. Put the ends in there and attach the belt. Oh, I see what they mean by use 12mm M5 for the short end and 60mm for the taller side. You can see this is the taller side, this is the shorter side. Simple enough. Let's go get our fastener bag. Gonna need some peanuts. These are my M512s. So let's get 4 of those out. And then M516s. M516s. I have those, right? One of the things I have been falling victim to is not all the sizes of fasteners were mentioned. And I'm assuming when the original creator developed this, he had a bunch of spare ones, didn't track everything. These look like M516s. Like M4 screws, the original M4 screws are just not tall enough, unfortunately. So I'm going to need 16, 3, 4, 6, 8. Math's hard. That's hard on a Saturday morning. I need a T-nut for sure. Okay, let's get some of the stuff out of the way. Excellent. Let's do a little swap. Yeah, these are no longer degreased. Let's log it. Let's bring this back into frame. Let's switch to the tripod camera. See how close we can get. Sorry for the infinite loop back there. Okay, so getting back to the instructions. I'm going to raise this so I get a little more clearance. Manually raising the x-axis is such a pain. Helps to have power and a control board. All right, move this to one side. Again, this is the back, that's the front. In the diagram, they're showing the front. This is kind of backwards from this layout, but I want to put the rod holder thingamabobbers, rod holders here first. So M12, M16, 2 T-nuts, and that's nice. Let's see how that looks above. Never mind. We'll use this camera. Actually, a little tray to hold the little bits. I'll repurpose this and create a tray on the top of this. It's always good to be a little organized, which I am chronically not. All right, so fit this in there. Oh, they also gave me some guidance. Install the left and right axle rod on the front face extrusion. All right, I'm going to follow their order of operations and not do what they said originally, which is to say we're going to go front first, which looks something like this. Guess it doesn't matter, but all right, cool. Let's see. We have our fasteners. Insert the 3D mill around 10 millimeters, and get my handy ruler. All right, 1 centimeter. You know, just a bit. Just so I have a frame of reference about halfway through. Yeah, looks like it's exactly 20 centimeters. Cool. Excellent, excellent. This is not precision measurements. There's tolerances. I'll just use my cheapo calipers. For those who are new to calipers, they're very handy, right? These are literally the cheapest ones I could get a hold of. Actually, let me do the overhead. Quick mini tutorial. Most are support metric as well as the wrong kind, and decimal base. Some have more precision. If you do a lot of machining, they have versions with fractions, which is awesome. But this is just a standard low-cost one. There's 3 ways you can use calipers. Most people use it for outside dimensions, right? So, these are 8mm rods. Cool. But you can also use for inside dimensions, which is awesome, for measuring holes and cutouts. Let's find a piece that should be floating around. All right, let's say I want to know what kind of hole this size is. It's probably, it's an N5 screw. Let's be very clear. Which is not very circular. Should have calibrated that printer better. But the last use feature is actually a depth gauge. If you look at the very end, this can also measure the depth of holes. It comes in really handy, for example, if you want to know how far something is in. You just run it and push it up against the edge, and boom. I can go a little bit further. And this is not a precise type of measurement, but it helps get things nicely aligned if you don't want to care about it. All right, last tip with calipers. So you turn them on, and they are at 0. So you make sure it's always at the edge, and then as you pull it out, you can see it corresponds to the physical printed measurement. But there's also a zeroing feature. So, for example, if I accidentally turned it on over here, it thinks that that is the 0 spot, so you start to get negative numbers, which generally you don't want to do. However, the zeroing feature is also a feature, not just for resetting if you screw it up, but for example, if you want to add an offset, say I want to get to exactly 10, let's say I want to drill a hole at 10, 15, and 20. Let's say 10 and 20. A bunch of different holes at 2 different lengths. So I get this to exactly 10. Now I can reset it. So now it's actually at 10. And for your, for your marking or whatever, you can know that space is 10. You can lock in the space if you want. But now if you want to add 5, so maybe you want to make it 15, now you can very easily jump it around to 15. And there's other things too. For example, if you want to have negative offsets, you want it at, it just helps with math. I don't use it that often, but it's handy notes there. All right, so we have the left rod quasi-positioned. Remove these placeholders. Great. And the right most piece, which again, I think has been resized since we last visited. I'm going to be reprinting a lot of parts in my future. I can already predict it. Easiest way I found to calibrate stuff is just to get it there. Ooh. And not bang it. The technology behind these and why they're so cheap is actually kind of cool. There's a bunch of teardown videos you can find online that explain it better, but basically there's effectively a barcode, an encoder inside each one of these, which makes it super easy to manufacture for cheap. Okay, that's about 10 millimeters as well. Huzzah! All right, now we have our components. With the short end, I'm going to guess I'm going to have a little bit of time, aren't I? Should I drill out those holes? I probably should have drilled out those holes originally, but I'm going to cheat and just use my reaming tool to see if that saves me the effort of getting out the drill bit and whatnot. Remember this from previous videos. It is not the same as drilling this out. It only touches the very edge of the opening. But I want to make forward progress if possible, as fast as possible, and I'm probably going to regret that decision to be lazy. Yeah, I'm going to regret that decision. So let's just do this the right way. I don't need more parts breaking on us. Uh, 5mm. Five. Block. Safety glasses. And listen, I like safety glasses. I think everyone should be using them. And I just have a healthy respect for cutting things. Okay. Let's go ahead and just drill these out real quick. That's it. Much better. Much, much better. All right. Put this back. Get this. You don't want to drill plastic too quickly because it does melt. So it's important if you're drilling out these holes that you take it a little bit slowly. That was a mistake for doing that one too quickly. Fortunately, that was the one that was the most not concentric. Or circular, so I wanted to give it a little extra push. Unplug the drill. I'm gonna put the drill bit away. Try to keep my small workspace as usable as possible. All right. Now we have our cleaned up holes. Time to set up our T-nuts. Long ones. Oh, it really matters to drill out those holes. Unless you're using heated inserts or what are those called? They're for wood. You screw in nuts back. I'll find the term. I'll post it later. If you do any woodworking, if you use any IKEA furniture as an example, they have these nuts. They're not rib nuts, but they're the same ilk. Design is fascinating. Let's see how this is a test fit. How these look. One interesting part of this design is this is definitely a different design. See how these are chamfered? This is not chamfered. It's going to make tightening these in a little bit more challenging, but it should hold. Not too worried. Yeah. And that's already in there. Let's do the same with this side. Along 16 millimeter, 12 millimeter. Get the thread starting. I was reading online, there's quite a big difference between T-nuts. Not just, there are different types of T-nuts, but they're just different manufacturing qualities. These are the cheapest, easiest to get from probably Amazon, maybe eBay. But there are higher quality ones. Certainly than this. Even Misumi, where I bought the rest of the hardware, extrusion and angle pieces, they make T-nuts that are supposed to be better quality. But I didn't opt for them. I was just daydreaming. I don't know. Trying to save money. Okay, those are physically positioned in there, in the front. Now I should slide the extrusion in there. Okay, let's switch to camera 1. Take off my safety glasses. Oh, quick aside about my safety glasses. These are little mementos from my time at Google, but not when I was at the campus. These were from Maker Faire, the San Mateo Maker Faire, the original Bay Area Maker Faire. And Google had booths every year. One year I volunteered, but they gave these away to everyone. So this is the original logo and the new alphabet logo. Also, I just needed 2, so kept them as handy things to protect my eyes. All right, so now we want to insert the carriage. I'm gonna clean up, or try to just run a blade through the belt holder again. I did that with the X and it helped quite a bit. It's still too snug of a fit. Actually, let's remove that. so it's not floating in the air. Just removing the belt holder from the white carriage. Not a whole lot of meat there. I don't know if you can, on camera, I don't know if you can see, but we're talking just a few threads. So I'll probably go upgrade those as well as the M4s here. I'll need to go calculate that. But in the meantime, I just want to take this and run a blade through it. A couple times, because if you look at standard cheapo belt, it's not quite all the way through. Surprising, but we'll make it work. Also, I think this will stretch over time. That's a little better fit, but I've tried to use this to push it in, and it's just not fitting. If I remember correctly, never had an issue with the Prusa Mark III, which is what a lot of these parts are modeled after. So I think it's a specific flaw in machine's tolerances or whatever. It's all good. Should hold it there pretty well. Putting all my force, that's not coming out. I'm just getting the number of teeth there are. That shouldn't matter. So I'll put this back, even with the very small amount of holding force we have, and come back and reinstall the belts. Again, forward progress is the name of the game. That's not even helping. It's there. Crap. Well, we'll see what happens. I'm just trying to get this on there. No, that's not going to hold at all. That is concerning. Before, it was holding a bit. Now, not at all. I want to see if I have any M4s in a junk bag just to get this thing going. I'd love to have at least 2 M4s. This is from some of the original printer. Need my thread gauge. This is a drill gauge. Not going to work for me. Thread gauge. Missing in action. I have calipers. Doesn't bode well. And these are all M5s. This is literally what I disassembled the other day. All right. It's okay. It's okay. Let's see what else we may have purloined. See, I saved every part from previous 3D printers for various reasons, including swapping out components in a pickle. This is a lot of the parts from previous 3D printer experimentation upgrades. That's interesting. Ooh, that is interesting indeed. This looks like an M4, quite a bit longer. If I can find a matching friend, that might get us past this stream. It's the old fan designs, fan mounts, old fans. Come on, you got it. There's got to be a second one. Hot end or heat break. Not looking promising. Oh, aha. Could this be it? A twin? What other goodies do I have in here? Don't get distracted. Okay. Are there any M4 nuts? That'd be rad. So many upgrades that I never got to. Oh. Actually, these are all upgrades I did. Never mind. If I can get these two just to stick on there without nuts, I will be very, very happy. Push these loose fitting ones. Well, that's interesting. All right. I'm hoping to get the same diameter. It's looking good. Let's put it in the wider. I assume this doesn't matter the direction. And just thread these through. Yeah, that's great. Does the order matter? Or the orientation matter? I assume this is just the dead center. Yeah, that shouldn't matter at all. Where is the second reclaimed screw? Huh. That would be funny if I lost it. Well, there we go. Remember what I said about being organized? Which I am not. I wanted to get the two screws kind of in the same spot. So one, this is going to be a lot better grip because of the length, but also I haven't threaded these yet, so they'll still be fresh plastic to bite into, which of course is not a good design, but will get us to our goal of finishing. Hopefully this extra long. Well, you know, it's actually not too bad. Yeah, it's extra long. Well, that might hit the belt. Might have to cut the bolts off. But that's way more secure than before, so I'm okay with that. Getting back to our instructions. Right out of the way. We want it to be like so. All right. Slide the y-axis end stop. Let's switch to cameras again. Make actually, that's a little bit. And the right one. Come on, bud. Okay. Want to make sure there's enough bite. This end. And this one could use a little. Oh. Okay, good. All right. We'll not do the switches yet, but we will put in the thread nuts. Okay, to the short side and the long side. Should really thread this first, or rather, insert the T-nuts first. Okay, everything is hunky-dory. Now, to center. All right. How about measuring here? Awesome. I have no idea what I'm doing. This should be 150. Make really small calipers as well as extra long ones. Same design. We just add more of that encoder onto a track, and you should be good to go. That is not 150. the outer spacing should be 150. Okay. Well, I don't think so. $42, $45, $43, $45, over this way a little bit, 139. Oh, other way. 4.28. This is about centered. Let's use this as a starting point. So what I measured was the distance between the outside of the inside of the rod and the let me show you above. Easier. I measured from here to here. So I took the rod outside and the channel inside. These channels are pretty high quality. Extrusions are pretty high quality, so I'm assuming that they're pretty even. I square them up both like mechanically at the edges, but also with a square. So I think they're spaced pretty well. I think the design may have changed again around recommended spacing. That the gap between, yeah, I just don't think the gap is exactly 150 anymore. All right. Get this in there first. Finger tight. Or just less than finger tight, so I can shift it around. Okay. And now, and out of the way. The same technique. We're measuring. It's 43.5. That's 42. Maybe a little bit that way. 42.75. A little bit more. Thank you. Okay, that's good enough for me for now. All right, see you, Alvaro. Thanks. Happy hacking later today. Try to pop in. Come on. Okay. It's not bad. So we'll do the switches later. What I want to do when I continue, get the motor, attach the Y motor, so the last motor we haven't attached, and use a single 12mm screw and 512, right? No, these are mounted with M3s. Missing information there. I truly need to go back and give all my edits. Alright, where are my M3 screws? Hidden away. Out of reach. Let's see if these will work. These are the first ones I grabbed. What size are these? No, they're too small. Probably M2.5s. Maybe there's a mix in here. Let's try 20. And 10s. Sorry, I have 10s. Something in between. Too hot, too cold. All right. Have to climb up again. I have a shelf with all my raw parts, which are very much off camera, so I'm going to be right above you. Not quite. And 3s. I have a bunch of plastic M2.5s. Why plastic M2.5s? Well, use a Raspberry Pi. You probably know that number because for some reason I can't explain, Raspberry Pi Foundation decided to make all the mounting holes for their Raspberry Pis 2.5mm, or an M2.5. Very uncommon, or very annoying, I should say. Certainly for me. Really? Oh, I see. I need 3 M3s with 3 mounting holes, but they're basically saying just use 1 for now, and which way does the motor get mounted? That's a good question. I mount it front facing. It's not a critical mounting decision. Do have a wiring guide which we can refer to. Yeah, it's definitely mounted down. At least in that one photo, so let's adhere to that. Let's grab some. Oh boy. Why is this taped? Oh, because it's broken. Oh, whatever. M3s are pretty common for most small-scale electronics, so I just have a ton of boxes of these. One project is to actually build a screw organizer, or a fastener organizer, I should say. One of these days. So, 15 and 12. There we go. go this way. That's about right. And switch cameras again. I should have drilled out all these holes. My fault. It's actually a bit of a science to designing machine screw holes for 3D printing. So you don't need inserts or necessarily you even have to use nuts. This is so strict. Forget what the actual percentage is, but you basically, if it's an M3 bolt machine screw, then X percentage smaller, just given the thread size. And it works pretty well. Also, if you're doing standoffs, there's a minimum wall thickness, again, for a given size machine screw, you need at least this much material. The 3D printing folks over at Adafruit, the Ruiz brothers, they've gone through a lot of that stuff. If you don't follow Adafruit on YouTube, you're missing out on great content, generally speaking, but also great tips and tricks for 3D printing. I started my journey in, this is going to take a while, 3D modeling, or I should say restart my journey with 3D modeling with their sort of walkthrough projects. I studied mechanical engineering for the first few years of college, learned SolidWorks and all the math, and then realized I don't like SolidWorks and all the math. So I had some background in 3D modeling before getting into it, but they really helped have a practical approach to, hey, I want to get this enclosure done. Here's all the skills you need to do that. Good explanation. So I highly recommend the Ruiz brothers on Adafruit's YouTube channel. There are actually other great resources for 3D modeling out there. Of course, if you're using Fusion 360, which is free for hobbyists and students, they have tutorials. They have an academy, which is actually pretty good. It's kind of geared toward people who have done 3D modeling before. So for me, starting there worked for me. However, not necessarily the best place to begin with. But I think they're probably ever expanding their knowledge base. Trying to remember, I was just listening to a podcast, and it was Chris Gamble's new podcast, Contextual Electronics, and he had a maker, designer, electronics enthusiast, I'll say Sophie Wong? I'll have to look that up. But she gave herself a challenge, 30 days of Autodesk or something, 30 days of 3D modeling, and she just spent literally every single day improving her skills in Fusion 360 and documented the whole thing and all their mistakes and all the gotchas she found. Apparently it's been helping a bunch of folks, especially who are experts in other areas, so they're not necessarily new makers. But yeah, you should find that at a link. Sophie Wong. I might have to get new Allen keys. Bummer. It's obvious that I use a lot of the M3 ones because that's the one that's actually messed up. I don't even have a bit I can put into a drill to speed things up, fortunately. I could drill out this hole, but we talked about that earlier. I'm characteristically lazy. Come on. I'm going to turn this on its side. I'm going to cheat and potentially break everything. Because I can't handle this manual process. There you go. What could... I won't say it. It's a bit faster. I get more rotations per reset. Alright. So far it's been a pretty good idea. See how much longer that stays true. I think this design is intended to enable tensioning, just like on the x-axis, which is great. I'm going to stop there because that's not moving, fortunately. I'll keep it going. I really need to get myself some hand tools. W-I-H-A. Oh boy. It'll be a long morning. At 2? Whatever. Forward progress, right, friends? That's the name of the game. All right. And next up, attach the belt to the Y holder, running the idler the motor loosely, then rotate the motor in place and screw in the... Should put the... Aha. Interesting design. All right. We have our spare belt. we will return this back to its side, because apparently that makes the most sense. Maybe I'm not going to scratch or break anything, but you never know. Attach this. So and feed that through. Interesting. How does this actually get fed? I'm going to have to look up something online. A lot of these instructions are based off the Prusa i3 Mark III instructions. You can't see what I'm seeing, huh? How do I add a view, a scene, screen grab? I'm experimenting here, folks. Browser display capture. Okay. Okay. Hoping that looks normal. Y-axis assembly? Yeah, these order of operations are completely different. That's all good. Oh, I see. Interesting. All right. So if you see that, let's switch back to... well, that works. Neat. All right. We'll feed this through the bottom. And kind of push it through. I need some tweezers to help. What I'll do is we'll cut this right there. Fantastic. Let's get 2 more screws that will probably be a real pain to insert. You know what? Don't feel like spending so much time messing around. Let's grab some 3mm drill bits. See if my chuck will fit it. Otherwise, I gotta go to Dremel. That should work. That won't work. There's absolutely no way to be able to get that drill in there. I don't have any hand drills either. One that I could find. I'm just gonna try to open this up a little bit. Okay, that was pretty unsuccessful. But let's keep moving forward. Oh boy. Not even close. Gotta be kidding me. Just a couple more turns and I'll get a little bit of it. Wow, this is really messed up. Okay, we have a bite. going to try to make this a little bit easier. Just to start. Definitely getting new Allen wrenches. I have this other set, but I'm missing some pieces. So maybe here. Aha. Let's try that one. Just. Oh, I closed the chat window. By the way, anyone who has any doubts about the quality of Prusa kit, I've built one from scratch, or built a kit. Great quality. That's kind of the reason why I wanted to do this particular set of upgrades, because it was based on some of the architectural and mechanical designs, while reusing most of the parts I already had from my original Wanhao Duplicator I3. Yeah, these little 3D printed designs you can get for Allen keys, wrenches keys. I keep on interchanging those, even though they're quite different. They give you a handle for nice. I'll print some of those eventually. So they add a something you can grab onto, and then use it almost like a T handle with standard whatever you have around Allen wrenches. I think is a pretty clever idea. It's almost there. This one is not even close. The fact that it is moving so easily is the wrong term, but with consistent pressure, which means that I'm just getting feedback on from the plastic. I don't even think it's registered with the motor itself. These stepper motors are threaded, mounting holes. Don't need a nut or anything, because you really couldn't put one if you wanted to. Just doing the design of where these tend to be mounted, the NEMA mounting holes. You can see it not well from your angle, right there. So again, I'm still still kind of floating there. Maybe that's just the part itself. Why is this one so hard to tighten? Hey. Let's call that done for now. So we have our belt, our pulley, move freely. I'm going to cut it. This is the last extra I have. So hopefully it's right length. Not tight enough. What does it say here? Attach the Y belt holder, run it around the idler, then rotate the motor into place. Should put the axis under tension. To further equally screw into 12. That's here. So let's try. We got all the things here. Let's do some controls. I think this is to hold the bolt in place, maybe? I think that this needs to be tighter. Oh, I see. So pull it. Pull it that way. Okay. Now we'll further tighten. Okay. Good friend to do this stripped. I'm doing is basically pushing the I don't know, M6 that's holding the belt in place right now. Let's see if I can give it a better shot. So see that bolt right there? By threading in these two M3s, it pushes it back. Ergo, tightening the belt. A very awkward location. I'm gonna make this just a little bit. Use once again calipers to measure I'm using the inside. It's about the same. Hey. All right, so where are we? Well, it says it should look like this. Guess what, friends? Kind of looks like that. Now it's time to reinstall the heat bed. So here's the thing with the heated bed. And the last section, all the electronics are all together. So I need to make room for that. So if that's the device thing, this is the original electronics. Obviously, besides the so with it is the heated bed, naturally. and the switches and connectors, cable chain, all that fun, those fun parts. So let's go back a little bit. Yeah, let's just leave that on. So this is the original, you can see, when, how. So original maker of the Duplicator I3, rebranded by many names. Just done a couple upgrades to it. Let's broke out this micro SD to full SD. It was just a little bit fiddly. I had a Raspberry Pi attached to this. Installed a bigger cooling fan for simply the reason I had one. And then you saw maybe earlier on the hot end side, I replaced it with an all metal metal Swiss. I don't know. Hot end. Maybe upgraded in the future. I don't know. This is a infinitely expensive, low cost machine. But that said, let's get to assembling. Now, I screwed up and forgot to label the axes. I labeled, put labels on the, let's see, I put labels on the different connectors for the power cable out of the way, just one less thing. The servos, the stepper motors rather, and not on the limit switches, which is fine. It's just kind of a pain. In the sense that now I have to trace either trial and error, which is probably what I'm going to do, or a bit of, or opening of the box. I think this is going to be the better way to work with this. It's the cable chain. Let me get you out of here. I'm going to guess this was the original the original Y-axis switch. This is where the Z-axis is. Z-axis, I think, is the one I had to glue. Where is the other switch? I'll say Y, Z. Aha. X, maybe? Let's try that. So remember in the previous step, I did not install the switch. Well, now we're going to install the switch. What size is this? These are probably the 2.15 that I was complaining about earlier. Oh, you stay where you are. I'm actually pretty excited to be making this much progress. I could stop here. I might stop in a few minutes just because I'm getting a little tired. But We're so close. So it's a crying shame if we can't get this at least all looking like it may work one day, as opposed to just a hodgepodge of parts. There's a good chance I might have to reprint most of these pieces. Gosh, this is already stripped? No way. Once I get this printer back in working order, though my Monoprice Select Mini with minimal upgrades did print generally PTG better than expected. That was that one part that one of the rod holders, it didn't have the facets. And I think I just should have turned off the heated bed, and it would have been fine. So in a real pinch, I can start printing those if this truly like cracks, the PCC did earlier. All right, and now for what we believe, hold on, before I start cabling things. Aha. Run the main cable between the rear legs. There's a piece that goes there. I'm assuming I want the heated bed to be hanging out the back, though. Yeah. So it's something along the lines of this. Which way does the switch orient? Okay. So it's like so. Do that. These limit switches are so delicate; they crack so easily. From experience. And even the low-end ones are more expensive than you would think. Especially if you want the nice soft bend there. So key is don't over tighten these, because then you're buying new ones. Want the snug in there? Ah, good sound. Makes me happy. Let's get the last bag of parts. Okay, well, there's a couple bags. That's why in a moment. Okay. Section 9, cabling. You and you. I'm going to put something down so I don't scratch up, or limit the amount of things I can scratch up on this printer. These things could always turn out to be terrible ideas. Okay. And so, have these pieces. It says run the cable between the rear legs, install the base holder under the printer with an M512. And a T-nut. M512. Okay. As far as I can tell, this is not a precision job. See how the fit is. Okay. Just for fun, get our M5 drill bit. You guessed it, safety glasses. I'll go for the multicolor one this time. Okay. And then, this is not printed great. How is this attached? M3s. Well, we have our drill out anyway, so let's get our M3 bits. Or whatever. There's not a whole lot of that thing, if it didn't crack, very thin walled. This print is a bad print. Fairly bad. It's too long. What size? Are you kidding? Dimensions don't make sense. Oh, great. If send this as well. Where is my sanding block? Sanding block is not currently useful. I'll use feeler files. Standard, straight edge, just to give it a little bit of a better fit. try. Well, that's kind of centered. Not really. Don't be lazy, John. Are you there? Okay. Whatevs. Ah, crap. Guess what, friends? Forgot to put the Tina on. All that positioning for nothing. All right. Allen wrenches. Wrong size. Okay. And 23s. Basically, just take everything else that's not going up top and put it through everything. See, on the main cable, like everything. Like so. And nope. Well, let's start this. Let's get this party started, huh? Take my glasses off. Cool. So that we can Come on. It's almost on there well. And this side, which is probably going to give it the last bit of rigidity we need, is not cooperating. So I need a newer key wrench to finish her up. It's not providing any mechanical strength, so that's good. All right. That looks good. What next? What next? What next? What next? Use the conduit fitting part. Okay. The y-axis end stop is screwed into the y-axis. An auto leveling sensor is being used using no end stop, otherwise the end stop Z part end stop is screwed directly into the tower extrusion and calibrated to your bed leveling. Well, where's the Z axis part? Aha! Okay, more drilling. Sorry. Drill? 3. I just don't want any more surprises, you know? Okay. I think I can pick it up now, but I have no idea. The question is, which side does the Z limit switch go? If there's any photos, might help. Let's put it on the side without the X motor. Let's just try that with this. Definitely, I know which side because the cable tie is connected. Which actually makes sense now that I think about it. So let's just feed this through. Switch cameras in the meantime. This will be the X to the Z. And I'll do the X in a hot second. Okay. File. Right, I need okay. We will calibrate that soon. Go on the inside? I'm not too worried about that, but I need this to be moved and sanded just a little bit. When you do sanding and filing, you should definitely rotate directions. So you're human. We're not equal creatures, perfectly symmetric. So you have biases on how you hold stuff and the angle. And so by switching directions every so often, you actually can normalize the differences between your own squishy self. There is nope. T-nut. Okay. Let's go somewhere here. I think. Already guess. And something like definitely not there. Because I said so. Let's get this a little closer again. Still too big. Oh boy. It's the smallest Allen wrench I have. That is disappointing. I have SAE. Oh, what's it? Oh wait, I have another set. Jam this or break it, or otherwise regret any actions I aggressively take. What happens when I'm all over here? Nope. Screw so long. Oh my gosh. Actually, I need second screw as well. 2.5? Or is it 2? What did everyone think? It might be 2. Might be even harder to come by. Nope, I think I'm gonna call it there for now. I am getting a bit burnt out. Let's get the camera at the right height. But to be honest, this is starting to look like a thing. We have, honestly, 95% of the mechanical and electronics done, which is super exciting. Just got some cable management, and then fire up. I'm thinking about doing another live stream either later today or tomorrow, hopefully to see if this thing will actually work once again. Anyway, if you're watching during the live stream, thanks for sticking with me on a Saturday. And if you are watching this in the future, hope you enjoyed it. Hope you learned something. If you're building the same build, I'd love to know in the comments below. And with that, I'll talk to you later. Cheers.